Hello, math humans. We're going to do E4 today. We're going to be talking about applications of exponential functions. So our objectives are that we're going to manage simple and compound interest. So let me explain the difference between the two. Simple interest would be what I call your big ticket items. So that might be a house, might be a car, a boat, an RV, all of those things, okay? Compound interest is often going to be an investment or you're going to borrow money, okay? So let's talk about the difference in the two formulas. For simple interest, the formula is A is equal to plus PRT, where P is the principal, can't spell, or your cost, and R is going to be your interest rate, and T is going to equal time. So you can leave the formula like this, or you can factor it to be 1 plus RT. Either is appropriate. Compound interest, on the other hand, gosh, I keep doing that, is going to be A is equal to P times 1 plus RT, and then let me check and make sure I can see the difference. So 1 plus R, and then we're going to raise it to the T. Every book writes the formula a little bit differently. So let's talk about the differences in the formula. P is still going to be the principal, or how much you're borrowing, or whatever. R is going to be your interest rate, and T is going to equal time. So let's look at the difference between the two formulas. This one is linear, which means that its graph is just a nice little line. But compound interest is an exponential function, and that means that it goes like that. And so we'll talk about the difference between the two personally as we go through our examples. So for example number 1, let me get out a piece of paper. So for example number 1, you're going to buy a car for $20,000 and you're going to finance it for 5 years at 3% interest. So this is typical when you purchase a car that you finance it for 5 years. The interest rates right now are fairly low, and then this could be just a semi-normal cost for a car if you're buying it new. So because this is simple interest, because it's a big ticket item, we buy a car, then that means it's going to be the formula A is equal to P times 1 plus RT. So my principal was the $20,000, and here's the 1. The rate is 0.03, okay, and then I'm going to finance it for 5 years, okay. So I'm going to show you how I would do that math in my calculator. I would do it all in one fell swoop. So I would do 20, and then 1 plus 0.03 times 5, and then I'm going to get $23,000, okay? So the first thing that we figured out is the car that you bought for 20, the total cost of the car, not including tax, title, and license, is going to be $23,000, okay? So now the next part says, what's the monthly payment? So A is going to equal 23. So you're paying $3,000 in interest for the benefit of using somebody else's money for 3 years. So now I want to figure out what my monthly payment is. So I would take that $23,000 and I would divide it by 5 years, and I make 12 payments per year because you pay once a month. So my years would cancel. So it's going to be 23 divided by 60, and your monthly payment would be $383.33, and this would be your monthly payment. Okay, So if you go in to buy a car, it's super easy to figure out how much the car is going to cost you. And remember, I did not include tax, title, and license. So tax, title, and license. Every car sales place, oops, spelled it wrong, is going to charge you for these. Remember, in Arizona, our tax rate is almost 10%. You pay a flat fee for the title and a flat fee for the license, okay? All right. So now let's move on to our second example, okay? And now we're going to buy a house. Woo-hoo! So you've graduated, you've completed trade school, and now you're going to buy a house. This is a little bit less than the average cost of a house in Flagstaff, so that's why I chose this number. We're going to finance it for 30 years at 4% interest. So this is actually a little bit high for the current interest rate for buying a house. Many houses are purchased on a 30-year note. In Japan, they're on a 100-year note. So watch what happens. So my A is equal to my principal times 1 plus RT. My principal was $300,000. Here's the 1. My interest rate is 0.04, and I'm going to finance it for 30 years. And if I do that math in my calculator, you're going to get $660,000. So A is equal to 660, comma 123. Now let me explain what that means. So they've taken your interest, this calculation right here is your interest, and added it to the principal. So even though the house only costs $300,000, because you are borrowing somebody's money for 30 years, their job is to make money for themselves, 4%, that house is now going to cost you over that 30 years $660,000. Here's how about that life for a Life 101 lesson. So now we still need to figure out our monthly payment. So we're going to take our $660,000, okay, and I'm going to make 30 years of payments, and I'm making 12 payments per year. So my years cancel, okay. Alrighty. So then now what I'm going to do is divide the 660,000 by 360. So 660 divided by 360, and you're going to get that your monthly payment is $1,833.33. Okay. The good news is, so I'm going to write that my payment is equal to $1,833.33. The good news is if you buy a house, you get to write off your interest, so part of this 4%. The bad news is it's a high monthly payment, and so you have to figure out if you can afford it, and this would be one of those ways that you can figure out what can you afford to buy by taking the cost that you buy it at and financing it typically for 30 years, and then figuring out what your monthly payment is. So it's great to be empowered when you walk into a conversation. So before I bring up the next example, I want to go back and talk about compound interest just quickly. So compound interest is an interesting concept. It's A is equal to P times 1 plus R raised to the T, okay? And so compound interest is an exponential function. So we saw in this example that this is a linear, and so that means that over time I could figure out what a house is worth or what my payments are going to be. Compound interest, on the other hand, is an exponential function, which means that the amount that you owe or the amount that you're potentially earning is growing really fast. Okay, so now let's do example number 3. Okay, and I still need to get another piece of paper out. So for example number 3, we're going to invest, so this is working in our favor, $1,000 in an account that pays interest compounded annually. So that means it's going to be compounded once a year at 5%. How much will your investment be worth in 10 years and then in 20 years? So my formula is P times 1 plus R raised to the T. So that's going to be, there's my $1,000 that I invested, and then 1 plus, our rate is always in decimal form, and then if I do it for 10 years, then that value, and I would do this in my calculator, is going to be 1628.89. So I would write A of 10 is equal to 1628.89. Well, if I want to calculate A of 20, then it's going to be that same $1,000, 1 plus 0.05 raised to the 20. And when I do that math, I'm going to get 2653.30. So A of 20 is going to equal my 2653.30. So when you are investing money, notice that this is compounded annually. If we have more frequent compounding periods, this equation changes a little bit, and we'll get to that potentially later. But now what I want to do is I want to talk about the other side of the coin, which would be credit cards. Okay? So now we're actually going to, oops, did I forget an example? Nope, I got it. Okay, so now what I want to do is I want to talk about, before we get to example 4, sorry, I'll just write it right here. I want to talk about compound interest, and then we're going to have different compounding periods. So for example, we said that our compound interest formula was P times 1 plus R raised to the T, and this was for compounded annually, meaning that it's once, I'll write that, once a year. Okay? But what if I change my formula and make it 1 plus R divided by N raised to the NT, where N is the number of compounding periods per year. So let's say if I want to compound monthly, there are 12 months in a year, so that would be my N. Let's say if I want to compound quarterly, then that means N would be equal to 4. Okay? This is the one that we're going to focus on because we're going to talk about what happens with your credit cards. So your credit card, the company that owns the credit card is big business, and their goal is to make money. And unfortunately, they're going to make money off of you because most people live outside of what happens. So we're going to walk through an example. But credit card companies make lots of money because we tend to live outside of our means. And remember that how much you owe is an exponential function, and that means that the amount that you owe is going to get really, really big. So now let's do example number 4. I'll cover up example 5. But you're going to buy a new set of tires for your truck, and you're going to put it on your credit card. It has a 25% annual percentage rate. Sometimes this is higher when you are younger, but even though I have had a credit card for many years, probably for like almost 50 years, my APR is still high, which means this is just how much the credit card is making off of what you don't pay. We're going to make a minimum payment, and the minimum payment on all credit cards is 1% a month, because remember, their job is to make money. Okay? So you're going to buy your $700 set of tires, and you're going to make the 1% payment. 1% of the 700 is going to be $7. And so the first month, you're going to pay $7, and so now you owe $693. So this was month 1. This was going to be when you purchase your tires, and then you make the minimum payment at the end of that month. Assuming that you made no additional purchases, that you put nothing else on your credit card, so we're going to assume away reality, and we're going to manage this one situation, so you didn't make any new purchases. Well, now your A is going to be P times 1 plus R divided by N raised to the NT. So now it's going to be 693, 1 plus, it's 25%, divided by 12, and then when we do that math in your calculator, you're going to get 707.44. I will tell you that this part gets to be tricky in your calculator, so I'm going to do 693 times 1 plus 0.25 divided by 12. Do not do this ahead of time because the round-off error will cause you to get the value wrong, and there's my 707. Okay, so now we're going to take our 707.44. We're going to subtract our 1%, which is 7.07. So this is my payment. This is the 1% payment. And when I do that, I'm going to get 700.307. Okay, so month 2, it doesn't seem like a very big deal. Okay, so now I'm going to go to month 3. So now you're going to take this new balance, so the 700.307, and 1 plus the 0.25 divided by 12 because the rate is the same. So we're going to do it for 1 month. And then when I do that, this is 714.96. So notice that in month 3, the tires that you bought for 700 are now up to 714. And remember, we didn't buy anything else new, and we're not putting any additional monies on our credit card. And so this amount, so in 1 month, your tires were now $7 more than you paid for it. In month 3, now it's at twice that amount. And if you keep going and going and going, and you continue not to pay more than that 1%, you're never going to pay this debt off. Okay, and then remember that for most Americans, we tend to live outside of our means, which means we spend more than we can pay for. Okay, so I want to go and just show you month 4. So month 4, I would take that 714.96 and I would subtract my minimum payment, 7.14, and that's 707.82. So in month 4, I would do the 707.82 because the compound interest is charged on your unpaid balance, and now it's 722.57. And then if you subtract your minimum payment minus the 722, and you get 715.35. And you can see that the amount that I'm owing is just going to continue to go up and up and up. That's why people get in trouble with their credit cards. So now that we've talked about compound interest, I want to talk about the fast cash places. And I actually did some research and had some entertaining phone conversations with our local in Flagstaff fast cash places. So typically, if you wanted to borrow $1,000 from a fast cash place, you might pay 30% interest, which is not that much unreasonable. The difference is that it's compounded daily. The interesting thing about the fast cash places is that if you unpay the balance at 3 weeks, your rate increases to 300%. It is basically legal extortion. If the interest rate goes up to 300%, that $1,000 that you borrowed because you thought you were in dire straits, you're never going to get out of debt from that. So I'm not actually going to do the example for you because it's just very depressing. But I want you to be very cautioned. Getting fast cash might seem nice up front, but in the long run, you're never going to be able to get out from under debt with that. And on that happy note, that is it for today. I will see you soon.